So the last thing we got is what we call the average rate of change, right? So average rate of change is basically the slope between any 2 points, right? And really what we talk about average rate of change, we talk about any function other than a linear function, right? Because linear function, we just calculate the slope. But if we want to calculate the rate of change or how much something is changing, let's say for quadratic, cubic, etc., then we find 2 points and we find the slope between these 2 points, right? And so we can kind of create a line that goes through those 2 points and basically find the slope of that line, right? And so that line that goes through those 2 points is what we call a secant line. And what we're really trying to do is just find the slope of that secant line. And so the notation we use is m of the secant line. M represents slope, right? Now, the slope that you're probably used to is y2 minus y1 over x2 minus x1. The only difference now is we're using function notation, right? So remember, your y is equal to f of x. It means the same thing. So when we have f of x1, it just means the first y value. F of x2, it just means the second y value, right? And to get those values, well, it says evaluate your function f at the x value 1, right? And so that's why we have this what we call average rate of change, or the slope, using function notation, right? But all it is your change in y over your change in x, right? So nothing we haven't seen before. The only difference now is that you are looking at it using function notation, right? So that's still y2 and that's still y1. But let's say we don't have a graph. How do we calculate y2, y1? Well, we figure out, we substitute numbers into the equation and we solve for them, right? So here's an example. It says find the average rate of change of this function on the interval -3 to -1, right? And it's a closed interval. So we can think of this as your x1 and this as your x2. So if I try to find the slope of the secant line, what we really want is f of x2 minus f of x1 over x2 minus x1. So how do we find f of x2? So f of x2 just means you're going to plug in your second x value, which in this case it's -1, into your function wherever you see an x, right? So we start off -2 parentheses, -1 squared plus 6. Now I'm going to go ahead and put this in parentheses just to remind me that is my f of 2, or f of x2. And then we're going to subtract, and I'm going to go ahead and use parentheses to remind me, hey, you need to subtract the whole thing, not just part of it, right? So then we got to figure out, okay, what is f of x1? Or in this case, we're going to plug in x, replace x with -3 wherever we see an x. So we have -3 quantity squared plus 6, and then at the denominator we have our x2, which is -1, minus our x1, which is -3. And then from here we just simplify, right? So if we kind of just go step by step, -1 squared is +1. +1 times -2 is -2. -2 plus 6 is 4. And then we have a minus. I'm going to leave the parentheses for now. So then we have -3 squared, which is +9. +9 times -2 is -18. -18 plus 6 is -12. And then down at the bottom, or the denominator, we have -1. That negative and that negative makes it positive, so we have +3. And then we're going to go ahead and simplify one more time, and that's going to give us negative and negative is a positive, so we have 4 plus 12, which is 16, divided by -1 plus 3 is 2, and then we can simplify that to 8. And so the average rate of change, right? So average rate of change is 8.